Hey everyone, so today I want to go over the basics of probability and applications of counting principles to probability. So here we go with Module 3, Chapter 14, Probability. My name is Heather McPherson and I hope you enjoy this lesson today. So by using the diagrams, can you show 6 spots on the 2 dice, 9 or more spots, and where the red die shows only 5? Well, before we can do that, we are going to have to make the diagrams. And so what we'll do is we're going to go to Excel. And here I already have the 6 die kind of started the table already. So this top one right here is going to be our red die. One. We're going to paint that red. And then this one to the side, to the left side, is going to be our green die. So we'll go ahead and make that green. So in order to figure this out, what we're going to do is make this a table. So highlight it all, and then you're going to go up here to the borders and just click all borders. So it makes it into a table. So for what it is the probability. You're going to have one, like the red die will have a 1, the green die will have a 1. So you have 1 and 1. And then you'll go ahead and hit tap the bottom corner of that one, and if you slide it down, it'll go ahead and finish that whole column for you. And so you're going to go ahead and do that for this one as well. You're going to have 2 for your red die, 1 for your green die, 3 for your red die, 1 for your green die, and so on until you finish the table. So I'm going to go ahead and finish this table real quick. And then again, on all of them, what you're going to do is just click the bottom corner and then bring it all the way down, and it'll finish the whole table for you. It's one good reason to use Excel, because instead of having to meticulously type all of this out, it's easy. You just drag it down, it completes it for you. So here we have our diagram for the possibilities for the red die and the green die being rolled. So let's go ahead and go back to the slideshow. And so here like I said, we want to show the spots for that show 6 spots on the 2 dice. So for A, we're going to have this diagram. Right here, I have it highlighted with the blue. You have the 1 and 5, which makes 6, 4 and 2 makes 6, 3 and 3 makes 6, and so on. So these are the ones that show the 6 spots on both dice. The next diagram is going to show the 9 or more spots, so it's yellow. Everything that's in this highlighted spot is going to be what you see as the 9 or more spots with the 2 dice. The last one we want to look at is just the 5 on the red die alone. So you see here in the purple that I've marked just what shows the 5 for the red die, not the green. And it also wants to know which of these events, A and B, B and C, or A and C, are mutually exclusive. So between these 3, A and B are mutually exclusive. So next we have, by using the following formula, can you demonstrate the probability that the number selected is greater than 89, less than 15, a multiple of 4, even or less than 32, even and less than 32, and even given that it is less than 32. And you got to watch the wording on these questions so that you know that it's not the same problem you're looking at. It's an or an and just don't let that mix you up while you're doing it. So the formula here is PE equals NE over NS. Wait a second. Those are letters I don't know. So how about we decide S is going to be the sample space. So anything that has an S, we know the sample space will be put there. And E equals the events. So in this example, the sample space is always going to be 100. So NS will always equal 100. And we'll need to know that for the following equations. So we're going to use this equation and know that NS is going to equal 100. So the first one, we want to know if you were to randomly select a 2-digit number from a sequence of random numbers obtained by repeatedly spinning a spinner, how many would be, what is the probability of it being greater than 89? So we have NE, which is the event, equals 99 minus 89 equals 10. So if we put NE is going to equal 10, and then NS, like we said before, is going to be 100. So it's 10 over 100 means that the probability is 0.10 or 10%. The next one we want to look at is less than 15. So that gives us the event is going to be 15. And again, the sample space is still going to be 100. So what you're going to do is replace the NE with 15 and NS with 100. So you have 15 over 100 equals 0.15. Easy. We're going to continue to do that for the next one, and it's a multiple of 4. So what we're going to do is take 99 divided by 4, and it's approximately 24. And since 0, 0 is still going to be a multiple, we are going to, sorry about that, we are going to say NE equals 25. So that makes 25 over 100, which means that the probability is 0.25, or the event is 0.25. Now, even or less, we have PE or F equals PE plus PF minus PE and F. So E is the event, and which is even. So out of the possibilities, E is going to be 50. There's 50 even possibilities. And then we have F, which is the number that is less than 32. So NF equals 32. So we're going to place these numbers into the equation, and you have 32 over 2 because we want E and F. So we have to divide F by 2 and half and get 16. So what we're going to have with the equation is PE or F equals PE equals 50 over 100 plus 32 over 100 minus 16 over 100. And we're going to change these into decimals just to make the equation a little bit easier. So you'll have equals 0.5 plus 0.32 minus 0.16. So PE or F is going to equal 0.66. Now, we already know that even in less than 32, PE and F is 0.16 because we learned that in the last lesson. So now what we want to know is that even given that it is less than 32. So it's a whole new equation here. So if you look at this equation, this is what we're going to use to figure out the even given that is less than 32. So P, A, and B is going to equal 0.16, just like the PE and F up here. And then PA is going to equal 0.32 because we're looking at 32 over 100. And so when you put that into a decimal, it's 0.32. So you have the equation equals 0.16 over 0.32, which then means that the even given that is less than 32 is still going to be 0.50, so half of it. Now we want to calculate the probability that a randomly chosen student is less than 5 feet, is 5 foot 6 inches, and more than 5 feet. Well, what we're given is the in the question, or in the information we're given, is all in inches, but it's asking for feet, right? So you gotta know the equation is px equals number of times outcome of x occurs divided by number of trials of the experiment. So there are 20 students, which we have been told in the question, and we want to convert feet into inches first. So what you would do, we're looking at 5 feet, is you're going to do 5 feet times 12 inches over feet, and then that equals 60 inches. And we are going to actually go back to Excel, and I'm going to show you the table. So here I wrote down, I've already plugged in all of the inches that were given in the question. And what we want to do is we want to convert this into feet. So over here on the side of 60, what I'm going to do is I'm going to go ahead and make this into a table. Like I said, go up here and hit all borders. And here you're going to hit, make sure you hit equals. Click over here so it lights up the 60, and you're going to divide it by 12. Hit enter, and it goes to 5 feet. So we know that 60 inches equals 5 feet. Again, you don't have to go individually with these. Go ahead and drag this corner all the way down, and you get all of your, it does the math for you, which I'm so thankful for because I don't want to do it meticulously. So we want to see this table though in a more organized way. So what you're going to do is you're going to highlight it all. And over here, let me move my face for a minute. You're going to hit sort and filter. And you're going to sort smallest to largest. And that puts it into numerical order, which makes it a lot easier to read. And what I'm also going to do is I'm going to color code this because we started with 5 feet. So right here, you have what you used for 5 feet. All of this is what is under 5 feet. All of this is over 5 feet. And so just so you can look at it a little bit more or easier, and we know anything under 60 inches is going to be less than 5 feet. Anything over 60 inches is over 5 feet, and 60 inches equals 5 feet. So once we get our table made, we can go ahead and start to answer the other questions. Go. And here's the table again. Just a little bit easier to read. Again, 60 inches is 5 feet. What's less than 5 feet? What's more than 5 feet? And so the first question is, what is less than 5 feet? So as we said before, right here in the red, we have 3 students that are less than 5 feet. So you have px equals 3 over 20 because there's 20 students altogether. 3 of them are less than. And so you have a probability of 0.15 of the students being less than 5 feet. The next thing we want to look at is which student is 5 foot 6 inches. Well, again, we know that 5 feet is 60 inches. 5 foot 6 is going to be 66 inches. And so here in the dark blue, I've gone ahead and highlighted it. We have 1 student. So it would be px equals 1 over 20 equals 0.05 students. That's your probability of being 5 foot 6. And last, we want to look at who is over 5 foot. So again, like I said, here in this light blue, all of these highlighted are over 5'6", or 5 foot, my bad. And that makes it 15 students. So your probability is going to be 15 over 20. So 75% of the students in this class are over 5 foot. So I hope by using Excel, you can, it makes it a little easier to look at and these tables to look at to learn probability. Next, we're going to use a Venn diagram, and we want to show how many students in this class speak either English or Japanese, or possibly both. So right here, we have a Venn diagram. On the left is English, right is Japanese, and that middle right here just shows which ones speak both languages. So first, we need to know a little bit of background information. So there are 27 students in the class, and the teacher says that 20 of the students speak English and 12 of the students speak Japanese. But wait, 20 plus 12 is 32. So that means there's some students that speak both languages, right? So how would we figure that out? Good question. So what we're going to do is we are going to create our Venn diagram again, but we're going to use the equation n A or B equals NA plus NB minus NAB. N and B. So NA or B equals 27 because there's 27 students in the class. And we know that NA is going to be 20. That's the 20 students that speak English, and NB is the 20 students that speak Japanese. We want to know how many speak both. So here's your equation. We want to make, since we're looking for how many speak both, this part of the equation needs to actually be on the left side. So we're going to add it to both sides, and you get this part of your equation. Now we need that 27 to be over on the left side, on the right side. And so we have 20 plus 12 minus 27. So we know that 5 students speak both English and Japanese. So by learning how many speak both languages, we can now figure out which out of which students speak only English and which only speak Japanese. So you would take the 20 students originally that spoke English and subtract the 5, which gives you 15. So we have 15 that speak only English. And the same with Japanese. We had 12 right here that spoke Japanese. You'll subtract 5 from that as well, and you get 7. So we know that only 7 speak strictly Japanese and 15 speak strictly English, and there are 5 that speak both languages in this class. Using the digits 1, 2, 3, 4, 5, 6, and 7, we want to create a table or diagram to show the following scenarios. Well, we want to know if repetition is not allowed, how many 3-digit numbers can be formed by using these digits? Well, there are 7 digits, so of course there are 7 choices for the first digit. Now, since repetition is not allowed, the second digit cannot be the first digit. So we're going to do 7 minus 1 equals 6. So that means the 6 choices for the second digit, and we're looking for 3 digits, right? So we're going to do that one more time. So you'll take 6 minus 1 equals 5. So 5 choices for the third digit. And in here I made just a little diagram. Digit 1 is 7 choices, digit 2 is 6 choices, digit 3 is 5 choices. Now what you'll do is you'll multiply those together, 7 times 6 times 5, and you get 210 options. And again, this is when repetition is not allowed. It's different when repetition is allowed. Which right here, we have to show how many of the numbers in part A begin with either of the digits 2, 3, or 4. So it's whatever it starts with. So we only have 3 options for the first digit, right? So 3 numbers for the first digit. But again, there's still 7 digits. So what you'll do is you'll take 7 minus 1 equals 6. So there are 6 numbers for the second digit, and there are 5 numbers for the third digit. Again, you'll multiply those together, 3 times 6 times 5, and that gives you 90 options for it to begin with 2, 3, or 4. And last, we want to know about them being even. So we have 1, 2, 3, 4, 5, 6, 7. And out of those, the numbers that are even are 2, 4, or 6. So the last digit could be 2, 4, or 6 to make it an even number. So the first digit, well, in this case, the last digit, there are 3 choices, 2, 4, or 6. Then we have another digit, which is going to be 7 minus 1 equals 6 choices. And the third digit in the number is going to be 6 minus 1, so 5 choices. Again, what we're going to do is multiply those together, 3 times 6 times 5, and you get 90 choices again. We have a state that has many different license plates, right? Well, in this state, you can either have 2 letters followed by 3 digits or 3 digits followed by 2 letters. So can we tell the probability of how many license plates can be made in that one state with 2 letters followed by 3 digits and 3 letters followed by 3 digits followed by 2 letters? The first example we're going to do, repetition is actually allowed. So what we need to know first, we have 2 letters, right? Well, how many letters are in the alphabet? There are 26 letters in the alphabet, so we know that there are 26 options for both letters since repetition is allowed. So you have 26 times 26, or 26 squared, which equals 676 2-letter combinations. And then we want the digits. There's 3 of them, right? Again, repetition is allowed, so you have 10 options for the 3 digits. So again, you'll have 10 times 10 times 10, or 10 cubed, which equals 1,000. Okay, that lets us know how many letters and digits, but how many license plates can we make? So what you're going to do for the 2 letters followed by 3 digits, you'll do 676, multiply that by 1,000, you get 676,000. So there are 676,000 combinations that can be made with 2 letters followed by 3 digits. Well, since they're the same, 3 digits followed by 2 letters, we want to know how many altogether. So it's going to be 676,000 plus 676,000, which equals 1,352,000 combinations for different license plates in this state. And again, this is when repetition is allowed. Now, what if repetition wasn't allowed? How many combinations can we get? So again, 26 letters in the alphabet, but wait, remember what I said, repetition isn't allowed this time. So you would have to do 26 letters for the first letter, and 26 minus 1 equals 25 for the second letter. Multiply those together, you get 650 2-letter combinations. Same with the digits. First choice, you have 10 options for the digit, but we can't use that. So you do 10 minus 1 equals 9, and 9 minus 1 equals 8. So in order to find the digits, we're going to multiply 10 times 9 times 8, and you get 720. So to get these combinations, you're still going to multiply 650 by 720, and you get 468,000 combinations for 2 letters followed by 3 digits. Again, it's the same for the 3 digits followed by the 2 letters, so you're going to add those together. 468,000 plus 468,000 equals 936,000 combinations for license plates. And this, again, like I said, is when repetition is not allowed. So I really hope that I gave you a little insight on probability and how to show each other, or yourself, how to come up with different probabilities with the different equations and the ways to use Excel in order to create tables and even PowerPoint to create the Venn diagrams that we use. So thank you, and hope you have a good day.